Lesson 6 of Chapter 1 is on function operations and also on composition of functions. We start off with taking three different functions, such as f of x, g of x, and h of x. And the directions say to find each function and its domain. So part A, the notation right here, is saying take f of x and add g of x. So if we do that, it would simply give us x squared plus 4x added to the square root of x plus 2. Now I use parentheses on this, but really those parentheses aren't necessary. And once we take the two functions, we have to try to simplify it. And here we are unable to simplify, so this is our answer. That is the sum of the two functions f of x and g of x. And then if we do the same type of thing for part B, they're asking for taking f of x and subtracting h of x this time. So if I take f of x, which is x squared plus 4x, and I subtract h of x, which is 3x minus 5, now you can see that the grouping symbols, the parentheses that I used, they are important because we have to distribute this negative sign. So that gives us x squared plus 4x minus 3x plus 5. Simplifying gives us an answer that looks like this. So part A was addition, part B is subtraction. Now there is a second part here because it talks about finding the domain. And so the domain of part B would be all real numbers. And that's because we don't have any fractions and we don't have any square roots. But the domain on part A would be all numbers greater than or equal to -2. Because if you put in a number smaller than -2, you'd end up with a negative inside of that square root. Part C now, again we've got same three functions. And so again the notation on part C is saying take f of x and multiply it by h of x. And so here that would give us something like that. We would FOIL it to get our simplified answer. Combine like terms and we get a simplified answer like that. Part D now is saying take h of x and divide by f of x. So if we were to do that, we'd have 3x minus 5 in the numerator. The denominator would have x squared plus 4x. Cannot do any simplification there. And now when we talk about the domain, let's see here, on part C, your domain would be all real numbers, because there's no fractions and there's no square roots. However, on part D, I would say that the domain is all real numbers except x cannot equal 0 and x cannot equal -4. How did I get those? Well, if you take the denominator, x squared plus 4x, and set it equal to 0, we can factor, and once you factor, you can see you get two values that make your denominator equal to 0, so those are your undefined values. Same kind of problem, different example. Here we have two functions. Here's f of x, and here's g of x. And so the notation, first thing we do is find, first thing we do is find f plus g of x. And that would give us x minus 4 plus the square root of 9 minus x squared. The next one is the difference. And that would be x minus 4 minus the square root of 9 minus x squared. The next one is the product. And that would be x minus 4 times the square root of 9 minus x squared. Nothing that you can do with that, you just have to leave it. And the last one is f divided by g of x would give us x minus 4 in the numerator. Denominator would be 9 minus x squared. So now for your domain. So the sum, the domain would be numbers between -3 and +3. That would be the same for the first three, but the last one, the domain would be numbers greater than -3, numbers less than +3. Now next we want to talk about composites. Composites is taking two functions. Here's f of x, here's g of x. And you can see the notation is a little bit different. So let's start with part C to begin with. This little circle between it, what that means is find f of g of 2. So we're going to put 2 inside g. And if we do that, we get a -2. Now I have to take -2 and put it inside f. And if we do that, we'd get 5. So that would be our answer for part C, f of g of 2. Working backwards, part B, what they're asking for here is find g of f of x. So we're going to have to put f of x inside of g. So to do that, putting f of x inside of g would look like this. And then we'd simplify that into x squared minus 3. And then part A, what they're asking for is find what you get when you take g of x and put it inside f of x. So if we take g of x and put it inside f of x, it would look like this. We'd have to simplify that by squaring the x minus 4. And then simplify into x squared minus 8x plus 17. So this is called composites. Let's do a similar example. There's 3 parts to it. Let's do example 2a, and let's find f of g of 3. Again, what that means is put 3 inside g, and if we do that, we get -4. Then take -4, put it inside f, and that would give us -11. Next thing we'll find is f of g of x. And again, what that means is take g of x, put it inside f of x. So if we were to do that, we would have something like this. Simplifying would give us 15 minus 3x squared plus 1, which would give us 16 minus 3x squared. And then our last one is to find g of f of x. And what that means is you're putting f of x inside g of x. So if we put f of x inside g of x, it should look like this. Simplifying it, we'd have 5 minus 9x squared plus 6x plus 1. Distribute that negative sign. Combine like terms. And we get our result.